Hello everyone. So today we're going to be learning about section 11-3. So it's still integration of trig function. So it's 11-3. So integration of trig functions. Trig functions. So again, make sure you have those rules handy because we're going to be using those in order to integrate trig functions. So today I would show you U-sub. So basically how to apply U-substitution in order to integrate the function. How do we do that? Again, idea is still the same. You have to pick a part of that equation. You have to set it equal to U, and then you just have to substitute everything in terms of U. That's how we do it. So let me just kind of go over a few rules here. So because you can't just set x equal to u, you cannot do that, because if you do that, basically it's not going to make any difference to that equation. That would still be the same. So first thing, you can make x equal to 0 u. So if you see two positive functions, take the higher degree function and set it equal to u. If you see one positive one and one with negative, then we take the negative function, we set it equal to u. So we pick the higher one. We actually prefer a part of that function over other. So if you see one positive and one fraction, so we prefer, oh, why would I put 1/2? So let me just say fraction instead. If you have a positive and a fraction, so we prefer fraction over the positive one. All right, so that's how we do it. First I'm going to show you by U-substitution, and then later on, I'm still going to show you pattern recognition, because sometimes that could work too. So either or. So let me start off with first example. So first one, I have sine x over cosine square x dx. Okay. I'm on page number 691, example number 6, part A. Okay, first thing, I would like to simplify this. So this is sine x. And then I would take the bottom one to the top, and I hope you remember, this is something else you need to understand. If the function itself has squares, so you got to rewrite this. How about if I take this to the top? This is how we rewrite it. And this becomes dx. Okay, now time to sets a part of this equation equal to u. So what is that? So I see sine x as a part of the function, and this is the second function. So I would set cosine x function, the part that's inside the negative exponent, that's going to be equal to u. Now this becomes du over dx. Okay, remember we take derivative. So now derivative of cosine function, it's sine negative sine. Now I'm just going to do cross product after this, because eventually I might need that. So let's just do cross product. It's du is equal to negative sine x, and it's dx. I'm just going to leave it up here. I'm just going to stop here just in case, depends on what I need. I'm just going to simplify more. So back to this original equation. Sine x would stay the same. Cosine x, which is equal to u, so I would replace that with u and -2, and I have dx. So I still have sine x and dx to replace. So what I see in this equation is sine x and dx is already there. Let's just solve this equation for sine x and dx. So I would divide by negative. So basically these two expressions are equal to negative du. I hope you understand. I replace sine x and dx in terms of du. So here I divided by negative to solve this equation for that part. Now rest is pretty much, I'm just going to factor out -1. So I have u to the -2 du left. Now integrate, how do we do it? This is just normal integral. I would add 1 and divide by that. This is -1, so u to the -1 over -1. And once I'm done integrating, so there's no integral, I would put c at the end. Simplify, negative becomes positive. I would do 1 over u. Why? Because you know u has -1 on the top, right? So I would just simplify by putting 1 over. Now last step, You just have to substitute this function here. So what is the derivative of this? So the derivative of 1 over u, oh my bad, you need to replace the function with that. So what is u equal to? U is equal to cosine, so I would say cosine x plus c. You can simplify more because I know 1 over cosine is equal to secant. You can even rewrite as this function. All right, so that's my first example. Now let's look at part B. So part B, I have 4 cosine square 4x sine 4x dx. Okay, first thing, you need to simplify the function if it needs to be. Like this one here, what I see is cosine has squares, so I would rewrite this. Okay, time to put a part of this equation equal to u. So this one has 2, this one has 1, so means I would set cosine 4x equal to, or I'm just going to write it on this side instead. Take derivative du over dx, cosine derivative of cosine 4x. It's negative sine 4x, and there should be, let me just put 4 here and negative. Here you go. Let's do cross product just in case we need it later on. 4x and, oops, times it by d, what? It's dx. Okay, back to original. So we already have 4. This part, let me pick a different color. This part is equal to u, so u squared. So I have this, this, and this left. So pretty much back to this, I have everything in this equation here except this negative. So that's one I would divide by negative. So basically what would happen is, and let me just erase this because that's not needed. So I would say it's negative u square, and rest of these, this whole part is equal to du negative. I already put it in front. Okay, now factor out negative, so this is u to the second, add 1, divide by that, so this becomes u to the third and over 3 and negative there, plus c, substitute at the end. So what's u equal to? Cosine 4x, and to the third power, you can write it like this, or you can even say cosine 4x to the third and over 3 plus c. Here you go, that's part C. Part B actually. One more. So let's say I have secant, this is part C. I have secant square x, and I have square root of tangent. First, I would simplify. Let's rewrite it. So this is secant x, and there's a square. I would move this one to top, and this becomes tangent x and negative 1/2, and there's dx. Okay, time to set something equal to u. Or how about if I, instead of U-substitution, how about if I show you pattern recognition for this, just in case if you want to try. So in order to apply pattern recognition, this is what we do. First thing, you need to identify the part that you think is the original equation. So for the original piece, again, I would still follow these rules. So if you see two positive pieces, so the part that has higher degree, that's going to be your original equation. Plus minus, the negative part would be your original equation. Positive and fraction, the part that has fraction would be the original equation. So same thing for this one, since I see positive and a negative fraction. So I know the part that has negative or the fraction in it, so that's going to be my original equation. Let's just say this is my original. Now, try recalling chain rule. Is the other part, is the leftover part, derivative of that or not? Okay, try recalling tangent. What's the derivative? Secant square. So I see, yeah, it completes the pattern. So this part just going to go away. Once it completes the pattern, it's just going to go away. So basically what I have is, let me just rewrite it. So what I have left is, isn't it? Right? Now I would just do normal integral. How do we do normal integration? So I would just add 1 and divide by that. Okay, now once I simplify, this is tangent x to positive 1/2 over positive 1/2 plus c, almost there. Now, this one, take the reciprocal, put it in front, so this becomes tangent x, and I would change it to radical and plus c, so that would be my answer. I have one more to show you. So let's say this is example number 5. Again, I'm going to show you pattern recognition, because again, if you could figure out the pattern, it's seriously, these problems are the easiest one, I would say. Okay, so let's say I see sine squared 3x and it's cosine 3x and it's dx. First step, you need to identify the original part. How about let's just rewrite it first so that you can actually see that happening. I would just rewrite this. This is what I have. Okay, so I know I need to identify my original equation. So now I see degree 2 here, I see degree 1. So the part that has highest degree, that's going to be original equation. So this is definitely my original equation. Now, in order to complete the pattern, is the other part derivative of that or not? Sine 3x, derivative would be cosine 3x and times 3. Why? Because angle is 3x. So what's missing? 3 is missing. So this is where you need to bring in 3 over 3. Now what completes the pattern? So this completes the pattern. So as this 3, factor out the stuff that's not needed. I would factor out 1/3. What's left? Sine 3x to the second power. Now time to do integral. So for the integral part, I would add 1, divide by that, simplify. So I have sine 3x to the third power over 3 times it by 1/3 and plus c, simplify. This becomes 1/9, and this 3, I can rewrite this as sine to the third power. 3x is the angle and plus c is my answer. So that's how we do it. Again, U-substitution works for every single problem. Pattern recognition, it's like, I would say it's kind of like 50-50. If you see that's happening, do it. But if not, then you actually have to do U-substitution at the end. So yeah, this is pretty much all. So if you have any question, you can just comment and I'll answer that. Thank you guys. Bye-bye.